In this video, we're going to talk about how to add vectors graphically. So let's say if this is vector A and this is vector B. How can we add these two vectors and draw the resultant vector? To add them, you could use the head to tail method. Simply draw the first vector exactly the way it is, and take the second vector and place the tail of the second vector on the tip of the first one. So vector B, I'm just going to redraw it right after I draw vector A. Now to draw the resultant vector, draw a line from the tail of the first vector to the tip of the second one. And that is the resultant vector. So R is the sum of vector A and B. Now, let's say if we want to draw the resultant vector where R is A minus B instead of A plus B. So we wish to subtract the two vectors instead of adding them. So if you wish to perform a vector subtraction, the first vector you can keep it the same because it didn't change. It's still positive A. Now we're adding negative B to it. So if positive B is in that direction, negative B is in the reverse. So now what I'm going to do is take this vector and put it on the tip of the first vector. So that's negative B. So the resultant vector R, you need to connect it from where you started, the initial position, to where you ended, the final position. So that's the resultant vector R. Now let's say if R is 2A plus 3B. How can we draw it this time? To draw 2A, you simply need to double the length of vector A. So that's called scalar multiplication. 3B, you need to triple the length of B. So it's going to be going in the same direction, but it's going to be 3 times as long. Now I may need to draw this on a new page. So this is 2A, and this is about 3B. So the resultant vector R is right there. Let's try some more examples. Let's say this is vector A and this is vector B. So go ahead and find the sum of vectors A and B. Also find the difference and find the value of 3A minus 2B. So let's start with the first one, A plus B. So let's draw the first vector the same way. So that's A, and then let's add B to it. So R is going that way towards quadrant 2. Now we can draw B first if we wanted to. So let's say if we started with B, and then if we drew A. Notice that R has the same length and it's in the same direction. So it really doesn't matter which one comes first. So these two, they both look like this. So that's R. Now go ahead and try the second one. Try A minus B. So A doesn't change, so I'm going to redraw A. Now, if positive B is towards the left, negative B is going to be in the opposite direction, that is towards the right. So then this is going to be R, which represents A minus B. Now try the last one, 3A minus 2B. So let's start with 3A. It's going to be 3 times as long. And negative 2B, so it's going to change direction, and it's going to be twice as long. So R is directed towards quadrant 1, and it's very long. Sometimes you may need to add 3 vectors graphically. So let's say this is A, and this is B, and this is C. So find the sum of A, B, and C. So it really doesn't matter which one you choose to start with. So I'm going to start with C. So redraw exactly the way you see it. And then I'm going to add B to it. And then I'm going to add A to it. So R is right there. So this little section, that little vector, is the sum of A, B, and C. Now let's find the vector sum of A minus B minus C. So let's say R is A minus B minus C. Draw a vector R, the resultant vector. So let's start with A. So A is going to the left. Next we have negative B. If positive B is directed down, negative B has to be going up. So that's negative B. And negative C is going in the other direction. So now we need to draw a line from this point to that point. I'm just messing up here. There we go. So that's the resultant vector. And if you want to, you can redraw it elsewhere. So it looks something like that. Now let's try one more example. Draw the vector 2a plus 3b minus 2c. So 2a is going to be twice as long, but in the same direction. 3b is 3 times as long. So let me redraw 2a somewhere else. Let's put it up here. 3b is going to be 3 times as long. And then negative 2c, which I really don't have the space for. So let's redraw 2a up here. And then 3b. And then negative 2c. So we got to change the direction and make it twice as long. So now the resultant vector is right there. So now you know how to add vectors graphically, and you know how to draw the resultant vector using the head to tail method. Now there is another method that you may want to be familiar with. So let's say if this is vector A and this is vector B. Where is the resultant vector? So if you have two vectors where the tip of both vectors starts at the same point, how can you draw the resultant vector without moving vector B to the tip of vector A? So there's something called the parallelogram method, and you want to turn this picture into a parallelogram. So you want to draw another line that's similar to vector A with the same size, and then vector B, you want to draw a line that's parallel to it. So notice that we have a parallelogram, and then draw a line from the initial point to the final point, and that is going to give you the resultant vector. So that's called the parallelogram method. Let's try two examples using it. So go ahead and find the vector sums of A and B using the parallelogram method. So let's draw a line parallel to A, and let's draw a line parallel to B. And then here is the resultant vector. Now let's do the same for the next one. Let's draw a line parallel to B and another one parallel to A. And so the resultant vector is right there. So that's how you can draw it using the parallelogram method.